If I want to solve this, so I have a W, okay, I have a vector W equal to some V1, V2, okay, alpha, beta. I want to solve this. How do I solve it? I want to what? Write alpha, beta, because alpha, beta is unknown. I'm saying this equal means this W can be represented as some linear combination of V1, V2, right? So I just need to find what is alpha, beta. If I can find alpha, beta, then I know what is W in this space. So I want to find this as my subject. So the idea will be, I write it something as another matrix, but now do this. So this is what I want. What is this? If I call this A, this is something like A inverse. So this is the idea of matrix inverse. So suppose I have 1, 2, 3, 4, 5, 6, x, y. I want to find x, y. That means something here give me 5, 6. Then what I need to do is, I call this A, right? I call this A. So I call this B. I call this x. So I have AX equal B. Now, if there exists A inverse, then I'm going to do is A inverse AX equal A inverse B. What I'm doing, I just multiply here something. I also multiply here something. You should know that multiply something on the left and multiply something on the right is totally different. AB is not BA. This is called non-commutative property. If AB is BA, then AB have very special structure. And if I want to go fancy, if AB equal BA, A and B share the same eigenvalue. Later, not now, okay? Once you have this thing is identity. Identity is 1 in matrix. So number 1, multiply anything, give you the number. In matrix, you also have something, multiply this matrix, give you that matrix. So this is 1 in matrix. And then what? Then this I is what? It means 1, right? So I times x also give you x. So I will now have this, and then I get this. So if I can find this, then I solve AX equal B. Then basically the calculation is how do you find A inverse. I want to find 1, 2, 3, 4 inverse. There are multiple ways. The first way is called Gaussian elimination. The second way is by using determinant formula. The third way is to do something called elementary matrix multiplication. So I want to find 1, 2, 3, 4 inverse. The idea is I want to make it into this form. This is 0, and then some question mark, question mark, question mark. I just want to do this. You draw a bar, and then you put the number here, 5, 6, right? Okay. You try to make this number 0. So this is called row 1, this is called row 2. I'm going to do this. Row 2 equal to row 2 minus 3 row 1. Whole row, subtract 3 times this whole row. Then it will give me what? 1, 2, 5, no change. Row 1 is row 1, okay? No change. Row 2 minus 3 times row 1. So 3 minus 3 times this is 0. 4 minus 3 times this is 6. So 4 minus 6, negative 2. Okay, 6 minus 3 times this, so 6 minus 15, negative 9. Okay, so this is what I get. Now I have this thing. I simplify by decoupling. What does it mean? So I have this, right? So this is same as 1x2y equal 5, 3x4y equal 6. But now suppose this number is gone. If this number is gone, so negative 9 times y give me negative 6. Then I can solve for y. And then after I solve for y, I put the value back here, I can solve for x. That's the idea. This is very easy. Okay? So basically this is called elementary Gaussian elimination. So you try to do this by getting this. What about 3 times 3 system? If you have 3 times 3 system, so basically the idea is you first make these two guys equal 0 by what? By row 2 equal to row 2 minus the ratio. If this is A, this is B, you do this, then this guy will become 0. And then row 3, you do the same thing. Okay? This is C. Then you will kill this and do the remaining thing. Then you now reduce to a smaller system. And then what? You repeat on Q this thing. What about the second way? I have this. It will be A matrix will be inverse determinant A and then cofactor of A. I write like this, okay. Then you may then wonder, what the heck is this? What the heck is this? Now I'm going to talk about this.